Please proceed, ma'am.
दास साहब नमस्कार।
नमस्कार
Namaskar, sir. Ma'am, kindly proceed.
Am I audible clearly?
Yes, sir. Yes, sir.
त्यागी साहब भी आएगा। नमस्कार त्यागी साहब।
Namaskar, namaskar.
Yeah, good afternoon, sir.
Good afternoon. How many people?
Ma'am, now it
49?
is live stream.
Now
Live
it's
streaming?
live stream. Okay,
Yeah.
live stream. Should we start?
Yeah.
Okay.
Live streaming.
Good afternoon, everyone. So welcome all to the weekly online lecture series on atmospheric dynamics and its applications to climate sciences, jointly hosted by South Asian Meteorological Association, SAMA, and Savitribai Phule Pune University. So today in the lecture series, we have lecture number 20, which will be delivered by Dr. Somenath Dutta, sir. And his lectures were since last 5 weeks. Last week we had a holiday, so today is the 6th lecture. It will be on atmospheric energetics. Before we proceed for his lecture, I would request Tyagi sir, Professor Tyagi sir, to please give welcome address.
Yeah, thank you, Rohini, and of course, our bundle of thanks goes to Somenath for volunteering to deliver 6 lectures on a very important topic of baroclinic, barotropic instability, and now today is on energetics. So complete, very core topics of the atmospheric dynamics have been covered by Dr. Somenath Dutta. And the special feature of these lectures were that it was not the typical PowerPoint presentations, but hands-on on the board, which I'm sure many of our academic colleagues have forgotten how to conduct classes in that fashion. So that was also a very important part of his lectures. And of course, the topics which were covered are very, very important, especially the instabilities, barotropic, baroclinic instability from the basics, and now the energetics which drives our weather and climate systems. So once again, thanks the Somenath's support for this lecture series, and to Sama also. So thank you so much, Somnath, and wish you all the best promoting both academically and operationally the meteorology, because you are heading a division which is very weather sensitive, and also very, I think people are very much aware of these. I think so. The service which you provide in Kolkata RMC is really commendable. So once again, thank you, and we look forward for your lecture.
Thank you, sir. Yeah, so now we all know and we are familiar with Somenath sir. So I request Somenath sir to please proceed with the lecture.
People are very much aware.
Thank you, sir. First of all, I wish to express my sincere thanks and gratitude to Somenath for giving me opportunity uh, uh, to share my little bit knowledge in this platform. So anyhow, so I am now sharing the screen, whiteboard. I hope this board is visible to everyone.
Yes, sir.
So now, by the terminology energetics, what we understand, energetics, we understand different form of atmospheric energy and their conversion. Different form. One is your different form. different forms, and another one, their conversion. So now we all know, because since our childhood we know that there are 8 types of energy, 7 or 8 type: magnetic energy, electrical energy, chemical energy, etc. But for driving and driving and maintaining the atmospheric motion, the major 3 forms of energies are there. What are those? One is your internal energy. Another one is your potential energy. And another one is your kinetic energy. Now, this internal energy is mainly due to the thermal status of the atmosphere, thermal state of the atmosphere. And it depends on the temperature actually. The internal energy, suppose if the specific heat is CV, and if capital T is the temperature in Kelvin of unit mass, then this is the internal energy for unit mass of the atmosphere. So now if I consider the globe, now let me consider that the globe is made up of thermocol, big thermocol, giant series thermocol. So now if we break the thermocol, you will get the small element, white element. Okay. So now this white element, each such element, let me think its volume is equal to d sigma. But it is infinitesimally small. So therefore, the density inside the volume is represented by the density at the center of this volume. So suppose if it is rho, then rho is the density of this volume. So if it is so, then volume of this infinitesimal element of the atmosphere is rho into d sigma. So therefore, internal energy of this infinitesimal volume, this will be is equal to rho into CV into T into d sigma. So therefore the global internal energy we will get by integrating it with respect to volume, and this we call it global internal energy. So we can understand that it is mainly due to the temperature only, So let us denote it by capital I. Okay. Similarly, in the following the same logic, the potential energy of an unit mass at some height z above the mean sea level, this is equal to G into Z. This we know very well. So let me denote it by small p. So therefore, the global potential energy, this will be equal to rho into G into Z d sigma, and this we called global potential energy. So that means we can understand, as we go up, our global potential energy, it is more at the higher level. So this generally we denote it by capital T. And the last, just suppose an unit mass is moving with a velocity v, then its kinetic energy, this will be is equal to v dot v by 2. This we know very well. So this is, let me denote it by small k. So therefore, following the same logic, the global kinetic energy, this will be equal to rho into v dot v by 2 d sigma. This we call, everywhere it is with respect to volume only. It is volume, and this is equal to, this we denote it by K. So these are the expression. Now we will go that the mechanism or the dynamical or physical process which are responsible for the change of ice, or the change of P, for the change of K. That we will see now. Okay, so now, so these are known as actually energy equation. Energy equation. For that actually, Dr. Syed Javed raise hands. So should we uh, attend his question or concern now, or?
Sir, we can take those questions in question answer section after your lecture.
Acha, acha, acha. Okay.
They can write their questions in QA box.
No problem, no problem. I will be happy to do that. Then after that only. Fine. So now let me go to their equation. So equations of global kinetic energy equation. Global kinetic energy equation, it looks like this. That global kinetic energy equation, I am not going to derive it. It can be derived. It can be derived. It is from the first law of thermodynamics. We know from the first law of thermodynamics that Q dot is equal to CV dt plus P into d alpha dt. This we know very well. This alpha dt. Okay, and this also we know, that is CV dt, and this will be is equal to P, because alpha is equal to 1 by rho. Alpha is equal to 1 by rho. Okay, so therefore it will be minus P by rho square into d rho dt. And here, if I use the continuity equation, then you will get CV dt, CV dt, then plus P into the divergence, because this is from our continuity equation. We know minus 1 by rho d rho dt is equal to divergence. It is your Q dot. So now, yeah, and there is one rho is there, of course. There is one rho is there. So both side, now if I multiply by rho, that you will get rho CV dt plus P into del dot V. So therefore, ultimately you are getting rho CV dt is equal to rho Q dot minus P into del dot V. So this you now integrate with respect to volume. With respect to volume, so this will be your, this is nothing but your rate of change of global kinetic energy, that is di dt, and this is equal to this one, rho into Q dot d sigma minus P into del dot V d sigma. Sigma is the volume. So therefore, this term is known as generation of global internal energy. So from here, one thing we can see that, and this term depends mainly on this Q dot, that is heating. that is heating. So therefore from here we can see that due to diabatic heating there is an increase in the internal energy. So we get two conclusion. One is your diabetic heating or cooling, heating or cooling results in the internal energy increase or decrease, increase or decrease. Second term, from the second term what we can see, if there is a net divergence, then you can see this integral will be positive, and as a result of which, due to this negative sign, di dt will be negative, so I will decrease. So now logic is very simple. If this term is positive, it means that there is a net divergence is taking place. And we all know very well that divergence physically explain expansion only. So therefore, if expansion of air takes place, we know from our basic thermodynamics, there will be cooling only. And due to the cooling, there will be decrease in temperature only, and due to that there will be a fall in the internal energy. So therefore from here, second thing what we see, that this flow chart we got ultimately divergence or convergence results in expansion or compression and results in cooling or heating and results in internal energy increase or internal energy decrease. This is the mechanism. So from this equation we may forget everything. Let us forget everything, but let us try to remember only these two lines. This is more than sufficient. So actually what happened, the globe, our atmosphere receives the energy in the form of internal energy only initially, due to through diabatic heating through our solar insolation. Then the divergence circulation convert it to something else. Okay, so that we will see now. Okay. So now next thing is your global potential energy equation. Global potential energy equation, straight away it will be like this: dp dt. This will be is equal to triple integration g into rho into w d sigma over sigma. So therefore from here we can see very well, if there is a net rising motion, over the globe, net rising motion, then or net sinking motion, then it leads to increase in the potential energy or decrease in the potential energy. So this is your global potential energy equation, that due to net rising motion. Now if I go to the global kinetic energy equation, then you will get for the global kinetic energy equation, we have to refer to our equation of motion, that is dv dt. We know very well. Friction, let us take the friction also. dv dt is equal to minus 1 by rho grad p. We know this is a pressure gradient force. Then minus g, this we know. Let us write plus g only. Sign will taken care. Then f. F. And sorry, another one thing also, horizontal, that is your uh, 2 into sorry, minus sign, minus 2 omega cross V, Fourier force. So now what we do generally, we do the dot product throughout the equation. Throughout the equation, we do the dot product. So if I do the dot product, then we'll get here minus 1 by rho V dot grad P, and here if I do the grad dot product with G, then we'll get only G into W. And here if I do the dot product, it will be V dot F, no problem. But here it will be equal to 0 because this quantity is perpendicular to V. It will be 0. Fine. So so therefore we get actually d dt of whatever, and this is, you can understand, that is V dot V by 2. That is your V dot V, that is your internal kinetic energy of the unit. Then throughout, you let me multiply by rho, let me multiply. Then this also I can write in this way. That is your, first of all, flux PV, I can write. Then next term we can write, that is your P into del dot V, this term it will be G rho into G into W, and this term you will get rho into V into F. So, and after that, if you just integrate with volume, then you will get this side dk dt, that is rate of change of global kinetic energy. This will be is equal to triple integral minus del dot PV volume integration. Then this one will get P del dot V volume integration. Then this term rho GW volume integration. Then this one rho V to F volume integration. So this term, actually, what is this one? We can understand this is nothing but the work done by or against the pressure force. This is nothing but the work done by and against the pressure force. Rather, I should say, instead of work done, I should say it is the flux of the work done by or against the pressure force. And we all can understand this flux is always across a boundary. And entire thing, if we see, then this is nothing but the flux convert with this minus sign, flux convergence or convergence of the flux of the work done by or against the pressure force across the boundary. Now, this will be significant, may be significant if the computation is made over a limited region. But if we take the entire globe, then this will be almost equal to 0. Actually, theoretically, it may be equal, it will be equal to 0 if we consider our global atmosphere is an isolated closed system. Okay, this is okay, and this is your global kinetic energy equation. So therefore, from this equation, what we learn that global kinetic energy number one, we can get that there will be if there is flux convergence, if there is flux convergence, or if it is divergence also, both the thing I can write together. Flux convergence or divergence of work done by or against pressure force, against pressure across the boundary, across the boundary, then this will result in increase in K or decrease in K. That means if convergence takes place, then increase, divergence. Second thing, if there is a net divergence, let us understand this thing. If there is net divergence, we all know that in case of divergence, there is an increase of wind speed in the downstream direction. That we know. Downwind speed increases with time in case of divergence. If it is so, that means in case of divergence, wind speed increases with time. Means in case of divergence, kinetic energy increases with time. So therefore, what we can see, if there is a net divergence, then due to the fact that in case of divergence, downwind speed increases, so that results in the increase in kinetic energy. So therefore, what we can see that, say again we get this thing, that if there is a net divergence or net convergence, if there is a net divergence means only wind divergence, I mean to say, then there will be an increase in kinetic energy. And if there is a net convergence, then there will be decrease in kinetic energy. Because in case of convergence, we know wind speed decreases. This also we can see. Then third, what we see, that if there is net rising motion, that in that case, this integral will be positive. And due to this negative sign, their kinetic energy will decrease. Now, question is, let us try to understand, if there is net rising motion, then there has to be convergence, strong convergence at the lower level. Otherwise, you cannot get the net rising motion. So there will be strong convergence. And just now we have learned, due to convergence, there is a decrease in kinetic energy. So we get that net rising motion results in a decrease in kinetic energy. But if there is a net sinking motion, we know if there is a net sinking motion, then sunken air immediately disperses away with a very strong speed. That means a sunken air, as they disperse away, their wind speed increases. There is a divergence, because wind once sinks, it diverges away. So divergence takes place. So and just now we read that due to divergence, there is increasing kinetic. So therefore, ultimately, what we have seen, that net rising or sinking results in the decrease in kinetic energy, and if there is a sinking, then there is an increase in kinetic energy. And this term, we are now left with the last term. The last term, this is nothing but the work done against the work. This is nothing but the work done against the frictional dissipative forces. This term is always negative. This term is always negative. Okay, this term is always negative. So therefore, due to this term, there is always decrease in the kinetic energy. So due to that, even though plus sign is there before, this entire sign, entire this thing, we generally denote it in literature as minus of dk. D stands for dissipation, the dissipation of kinetic energy. Through friction, kinetic energy only dissipated. Okay, so for we read what we read, that uh, due to friction, always friction friction results in dissipation of kinetic energy. Dissipation of kinetic. So therefore, in a nutshell, what we have understood, that due to solar heating, first there is a generation of internal energy. Solar generation. So there is certain amount of internal energy is there, and this internal energy, it gets converted to kinetic energy through divergence circulation. Divergence circulation means convergence, divergence, both are included. Divergence circulation, and this K gets dissipated. K gets dissipated, actually get dissipated due to this thing. And not only that, another thing also, due to friction sometime causes some heating also. So that's why to some extent it helps in increasing the internal energy also. So this is a general thing. Now special case, that suppose our atmosphere is, we know that if I consider the entire global, then atmosphere is hydrostatic. Atmosphere is hydrostatic, and atmosphere is stably stratified. Stably stratified. Atmosphere is stably stratified. Since it is hydrostatic, it implies no net vertical acceleration. That means if initially no vertical motion, then there will be no vertical motion. That means no growth. Vertical growth is not there. No net vertical acceleration. Vertical acceleration. And stably stratified means theta lines are quasi-horizontal. Quasi-horizontal. That means lines looks like this. Suppose this is your theta 0. This is your, say, theta 0 plus delta theta. This is another one. Theta 0 plus 2 delta theta, etc., etc. This thing is there. Okay. So no net vertical motion, this thing there. So now, one thing I would like to show, I will first try to explain in an intuitive manner, that first of all, if the atmosphere is having these two conditions right now, then the configuration of the atmosphere under these two conditions, we call it reference configuration. Reference configuration. Reference configuration of the atmosphere. Now, I would like to show that in the reference configuration, potential energy is proportional to internal energy. I will show in an intuitive manner. So how I will do that? First of all, I will show that if I attempt to increase potential energy, then that will amount to increase in internal energy also, and the vice versa. Okay. So for that, actually, let me consider one column of the atmosphere with unit cross section, which is extended from mean sea level up to top of the atmosphere. Top of the atmosphere is the top. So now, if I want to increase the potential energy of the atmosphere, so therefore, whatever air is there inside, that air has to move up, isn't it? Because potential energy we have seen 0W, isn't it? So therefore, if I want to increase potential energy, that should be net vertical motion. Follow? So now this net vertical motion requires a net convergence here. Net convergence here. Net convergence here. Now this net convergence gives rise to, there is an increase in temperature that we have already seen, because due to convergence, what happens? Compression of air takes place, and due to compression, heating takes place. If temperature increases, so if temperature increases means there is an increase in internal energy. So therefore, what we have seen, if I increase potential energy, that implies there is an increase in internal energy also. Even suppose if I want to say decrease the potential energy, then in that case what will happen? Just opposite thing will happen. This is a column, this is a column, so therefore there should be net sinking motion, and that sinking motion will give rise to outflow, and that outflow results in expansion. Expansion results in decrease in temperature, and decrease in temperature results in decrease in internal energy. So therefore, we have seen if I want to increase potential energy or decrease potential energy, similar type of increase or decrease in internal energy will take place. So one side we have seen. Another one side. So now suppose I want, again I have this column from mean sea level up to top of the atmosphere. Top of the atmosphere. So again, I want to increase the internal energy. If I want to increase the internal energy, then what will happen? I have to increase the temperature of the air inside. If I increase the temperature, then air will be warm, and air will warm and air will expand and it will move up. It will rise, and as it rise, what will happen? There will be a net rising motion, which will result in a net increase in potential energy. So therefore, what we have seen, that increase in internal energy implies increase in potential energy. In a similar way, if I want to decrease the internal energy, so then we have to decrease the temperature. That means you have to cool the air, and if you cool the air, then air will relatively become heavier and it will come down. So therefore, there will be a downward motion. As a result of which there will be a decrease in the potential energy. So therefore, what we have learned, that if I increase or decrease in the internal energy, there will be a similar increase and decrease in the potential energy. So if I mathematically, we know, when we can show one implies others, then what we say that both are proportional to each other. Both are proportional to each other. Actually, we just a joke. Sometime in my class, I used to take the analogy. I am a bit superstitious person. Every day after taking bath in my house, there are a lot of murtis of Lord Vishnu. Balaji is there, Krishna is there. That is your Shankar Chakra Gada Padmadhari, our Vishnu is also there. And I used to namaskar. And definitely it takes time. So one day my daughter called, tell me, Dad, I understand they are all incarnation of Vishnu only. You can save your time. You can take just one photo, whoever you like more, Vishnu or Krishna or your Balaji, and just worship one. It will be your purpose will be solved. Here also it is the same. P and I in such atmosphere not necessarily to exist as two different entity. Both are actually qualitatively indicating the same. Due to that, instead of I and P separately, to express their joint presentation, there is another one quantity is there. The name of the quantity is total potential energy. Total potential energy. And this total potential energy, it is defined as potential energy plus internal energy. So therefore, I need not to separately take care internal energy and potential energy. I can just take care of total potential energy, and this will serve my taking care of potential energy and internal energy. Okay, total potential. Now, another one thing. So if the atmosphere is in a reference state of configuration, then in that case, first of all, the theta lines are parallel to each other. The most important thing, theta line, I have explained it is okay. In a stably stratified means, stably stratified means heavier masses are below and lighter mass are above that. Heavier masses are below, lighter masses are above that. If it is so, then we have read during our graduation or 11, 12 science that in that case, the center of mass will be definitely towards the heavier mass only. That means center of mass will be at a relatively lower altitude. And since it is the hydrostatic, so therefore there is no vertical growth. So therefore the center of gravity of the atmosphere with this reference configuration will be at its least elevation. What does it mean? It means that global potential energy in the reference configuration is least. And if it is so, then we can understand, since P and I is what is called proportional to each other in such atmosphere. So therefore, I reference, this is also is least. This is also least. If it is so, so therefore, we can understand that total potential energy in the reference configuration is least. Now, we all know very well that even though if I consider the globally averaged condition of the atmosphere, of course, we will have our atmosphere is stably stratified and hydrostatically stable. But every part of the atmosphere at every time cannot have such configuration, because had it been so, then we would not have got any weather at all. We would not have got any weather at all. So therefore, even though this reference configuration may be there in a globally averaged picture of the atmosphere, but if you consider a limited part of the atmosphere at some time, that time the observed configuration, in the observed configuration, that observed configuration may not be same as observed configuration may not be same as the referenced configuration. Referenced configuration may not be same. If it is so, then total potential energy in the observed configuration cannot be same as the total potential energy in the reference configuration. If it is not same, means either it has to be more than this or it will be less than this, but it cannot be less than this, because we have already seen this is always least. It is always there. So therefore, what is that? That means total potential energy of the atmosphere in the observed configuration exceeds the total potential energy in the reference configuration. Okay, and this difference, total potential energy observed minus total potential energy reference, this difference, this is known as available potential energy. Available potential energy. Potential energy. Available potential energy. What does it mean? Because as I told you that in the observed configuration, hydrostatic and your this thing, what is called stably stratified, both the condition cannot meet actually. So hydrostatic is a much more robust and strong condition, but stable stratification is not. If it is not stably stratified, then what will happen? I told you that in a stably stratified configuration, theta lines are quasi-horizontal. So if the stable stratification is not there, then what happen, you know, the theta lines become quasi-vertical. They cannot, that means theta lines may be like this. Theta lines might be like this, like this, like this. So this may be theta naught. This may be theta naught plus 1. This may be theta naught plus 2. You may not be happy with 1. 5. Let me write 5. Theta naught plus 10. Theta naught plus 15. Like that it is there. This line is there. And now you consider any vertical plane, vertical level. Say Z is equal to, say, some ZL something. Okay. So now look at 2 points on the same level. This one and this one. Now at this point, tempered theta value will be how much? It may be 5, 10, 15. That means theta naught plus 7.5. 7 pakadaiye. And this may be your theta naught plus 12. That means at the same level, this air is potentially cooler. This air is potentially warmer. As a result of which, a vertical motion will set in. Vertical motion will set in. Vertical motion will set in. And this vertical motion, once set in, it requires kinetic energy. Where from it will get the kinetic energy? This is this one. This much of the potential energy, this much of the total potential energy in the observed configuration is only available for conversion to kinetic energy required to execute this vertical motion, required to stabilize it again. If due to this vertical motion, what will happen? This theta lines, which is now quasi horizontal, it will, with time, it will become again quasi horizontal. Okay, so this is available potential energy. The derivation of the available potential energy, it is a very lengthy derivation. I am not going there, but available potential energy, if you take the expression, it looks like this. That is T prime square bar, rather over bar, we can say, and 2 into sigma into P, and this is your, say, dz from 0 to infinity, that is top of the atmosphere, and here some constants are there. It looks like this actually, T prime square bar. So this you can understand, this is nothing but your variance of the temperature. This is the variance of the temperature. Variance of the temperature, we have to calculate the variance of the temperature at every level. And this variance is areal variance. It is very simple thing. Let us consider the atmosphere is consisting of several levels, say as 1000 HPA level, 925 HPA level, then say 850, 700, 500, this level. Now, you take any level, at every level there are many points are there. Those many, and every points are having their temperature. Take the variance of those temperature. This will be the variance of one level. Similarly, you go on calculating the variance of all the levels and you integrate it, vertical integrate. This gives you the measure of available potential. From here, one thing is very, very clear. Just suppose if you don't have the horizontal temperature gradient, can we have still any amount of available potential energy? You can see it is zero. It is zero because this T prime, how you will get T prime? T prime is nothing but your del T del X dx plus del T del Y dy. This is nothing but this one only. So this is what? This is nothing but your temperature gradient dot dr. So therefore, you can see if there is no horizontal temperature gradient, then this will be equal to 0. This will be equal to 0. So there will be no variance. So there will be no available potential energy. So thus, one very important conclusion we can say that available potential energy is a measure of baroclinicity of our atmosphere, because in a barotropic atmosphere, you can understand available potential energy is just equal to 0. More the baroclinicity, more the available potential energy. That means more operational language, more the horizontal temperature gradient, more the available potential energy, which is happening. Actually, there are old theory of monsoon. SATs are available already. SATs are there. Das Sab is there. Our Professor Rao Sab is there. Mohanty sirs are there. Taggi sirs are there. All my teachers, they have already explained. They will again explain if necessary that monsoon generally, it is also popularly known as, it is a gigantic sea bridge. And this gigantic sea bridge is mainly driven by the land ocean temperature contrast, because during the summer season, northern hemisphere is very hot, mainly northern latitude, our Jacob, our northern latitude, and whereas our southern hemisphere, it is cold because they are winter season then. So this temperature gradient, it builds up during the entire summer season, and temperature gradient builds up means available potential energy builds up, and this available potential energy is only the reservoir of all energy of the monsoon circulation. And then what happened? There is some mechanism is there through which the available potential energy is converted to converted to your kinetic energy. And this you know very well. Just now we have seen that internal energy is converted to kinetic energy through divergence circulation. It happens so because we know that in the northern hemisphere we are having a low pressure area over Jacoba. Strong low pressure area is there due to heating, and in the over the southern hemisphere there is a very strong high pressure area is also there, that we know very well, that is masculine high, and this pressure temperature difference leading to this pressure difference gives rise to that convergence from high pressure area to the low pressure. That means divergence circulation itself. Divergence. And due to that, what happened? Due to that, what happened? You can understand in the ground there is a flow, southerly flow, and then in the northern latitude there is a rising motion. That means rising motion is taking place. Rising motion is taking place over relatively warmer area. Okay, and in the return flow at the upper level, that is from northern hemisphere northern latitude to the southern hemisphere, and then sinking motion over your masculine over this area. So this completes one thermally direct circulation. This is actually opposite to our Hadley circulation. This is your mean monsoon circulation actually. That's how it is fine, na? This am I correct? Yes, this is actually mean monsoon circulation. This is a typically divergent circulation, and this circulation actually converts the kinetic energy to the available potential energy to the kinetic energy. But you try to understand this kinetic energy, it is just divergent kinetic. Now, one thing I would like to show that, because in the atmosphere we see sometime just translation type of motion. Sometime in the atmosphere we see divergence or convergence. Sometime we are seeing your rotational motion in case of depression, low, etc. So now question is that when there is just a low pressure area, then we know very well that is air from the surrounding, they just rush. And when they rush, this is nothing but your divergent motion only. There is nothing but divergent motion. But after that, if you, and due to Coriolis force, of course, it attains some what is called cyclonic curvature. This is fine. But if you want this cyclonic circulation to rotate in a faster motion, so that means you require some rotational kinetic energy itself. So actually there is a theorem is there, you know, Helmholtz theorem. This Helmholtz theorem says that is our wind vector. I can divide into two parts. One part we call the rotational part. Another one part we call divergent part. And if I, and why it is called rotational part or it is called divergence part, I am telling you, because if I take the take the divergence of the wind, actually you will get, it is the divergence of this part only, that is V chi. And if I take the vorticity, that is del cross V, that is vorticity, then actually you will get this one only, that is your this del cross V chi itself, V psi itself. This chi is known as velocity potential and psi is known as your stream function. Actually that vorticity, this component you can express in terms of this one, del square vorticity, you can get this is equal to del square psi, and the divergence you will get, this is equal to minus del square chi. So now you may think that actually how we will get this rotational wind and this wind, what is called rotational wind and divergent wind, very simple thing, because that's algorithm is very simple. First you take the observed graded wind data. From the observed wind graded data, first you calculate at every point zeta and d. Then you solve these two equations. These two equations are Poisson equation. Relaxation method. Using relaxation method, you can solve this Poisson equation, these two Poisson equation at each and every point. And once you find out, once you solve this equation, then at every grid point you can find out psi, and at every grid point you can find out chi. You can find out, and once you find out, then you can find out its u component and v component, because u component of that is rotational wind, this is equal to del psi del y, and v component of the rotational wind, this is, we know, this is your del psi del x. You can find out, finite difference technique apply karke you can find out these two. And similarly, after calculating this, you can find out, because you can find out u chi is equal to del chi del x, maybe minus sign may be there in both cases, and v chi is equal to minus del chi del y. So you can find out. So therefore separately you can find out rotational wind, you can find out divergent wind. Okay, divergent, it is a very good exercise. I will encourage all the trainees, just take the graded data from any site and you just do it, because nowadays packages are available for Poisson equation solver. It is available, and you try to get it, and after getting, you try to map on a map that is rotational wind, how it looks, rotation divergent wind, how it will look. You will get a very nice picture, and our understanding will be very, very clear. So what I was telling you, that actually through the divergence circulation, A first gets transformed to D, that is KD, kinetic energy for the divergent motion. But only kinetic energy for the divergent motion is not sufficient. If it is so, then in that case, your cross equatorial flow may be fine, excellent, but you may not get any low pressure system. But even if a low pressure system form, it will be very difficult for it to get intensified. For that, actually, you require rotational kinetic energy, and the source of the rotational kinetic energy is only the conversion from divergent kinetic energy to rotational kinetic energy, So now I will show a few slides only. Okay, I will finish, sir. I am taking, I think, more time, or just 5 minutes. I think I may take. Is it okay? 5 minutes?
Yeah.
Yes, sir, you can continue.
Okay,
Right.
fine. Now, yeah, look at this equation, sir. This equation.
Excuse me, sir, your screen is not visible.
Screen is not visible. Okay. So, I have to share, no? Sorry. I think now it is visible, no?
Yes, sir.
It is from Krishnamurthy et al. 1998 only. Very fundamental papers, Asian summer monsoon. Yeah. So here, actually, let us look at this equation. Okay. So this rotational kinetic energy is generated mainly due to this one, that is conversion from divergent kinetic energy to rotational kinetic energy. So now it has many terms that you let us forget. Now their explanation, let us see one by one explanation. This is equal to this one. The first term we can write like this. Now here we can see this is nothing but your absolute vorticity. And we know these are some known facts are there, that rotational kinetic energy is perpendicular to the gradient of the streamline. That is rotational kinetic energy is parallel to the isolines of psi. I have tried to draw. You can see this is that black color wind. This is your rotational kinetic energy. This is your rotational wind. V psi is a rotational wind. You can see these are all parallel to the psi lines. Okay. Acha. We know that this one, and parallel to isolines is the opposite to and second one, that is divergent kinetic energy, that is V chi is opposite to grad chi. I have tried to do, sir. This is your V chi, red line V chi, and grad chi is just opposite to that. These are the chi lines. Red lines are chi lines. You see chi 0 delta 1, chi is increasing this direction. That means grad chi is in this direction and V chi is in this direction. Okay. So that is there. So now this quantity grad psi cross grad chi, it becomes equal to this one. So therefore conclusion is this. Thus for a given absolute vorticity, there is a positive conversion from divergent kinetic energy to rotational kinetic energy, that is maximum when the divergent wind is perpendicular to the rotation. It is rotational wind maximum, and to the left of the rotational. That is, if the southerly wind becomes southwesterly, or northerly wind become northeasterly. Okay, so now, so parallelly I can show this one also. That means southerly wind become southwesterly, northerly wind become northeasterly. If it is so, then only there is a conversion from divergent kinetic energy to rotational kinetic energy. Is that is for these two terms. Now next term it can be shown, it is this, and this is. Now if we look at this is what, this much, this is nothing but your vertical flux of V psi. Vertical, because omega is the vertical velocity, vertical flux of the rotational wind in the presence of vertical share of the divergence wind. So that's why it is written, this is nothing but the vertical flux of rotational wind in presence of vertical share of the divergent wind. Now if we consider a cyclone, we know there is low level convergence and there is upper level divergence, which clearly indicates or ensures the existence of vertical share of the divergent wind. And rising and sinking lines of the second, we know very well, in a cyclone there is a secondary circulation is also there. Okay, secondary circulation is taking place over that that area, what is called after I, what is that, intense cloud region, over cloud, what is I region, the next region, sir? I region, then your wall cloud region. In the wall cloud region where deep convection, all this taking place. So their rising motion takes place, rising and sinking lines of the secondary circulation. That means rising motion over the wall cloud region and sinking motion to the outer region and over the I region. It performs the task of transporting the rotational wind in the vertical direction. That is, rising line transports cyclonic rotation upwards and the sinking line transport the anticyclonic rotation downward. Okay, so this is another one mechanism through which divergent energy can be converted to rotational kinetic energy. And third one is a very simple thing. Third one is nothing but that given one certain amount of rotational kinetic energy, it will increase if there is convergence and it will decrease if there is a divergence. Okay, And then there is another one scheme is there, which was introduced by our Krishnamurti, etc. That is your that is your zonal kinetic energy, zonal energy, and eddy energy actually. So there are many mechanisms are there. You can see, we can see there. That is your zonal kinetic energy gets converted to zonal kinetic energy. Zonal available potential energy gets converted to zonal kinetic energy due to this, what I have explained actually, that is rising motion of warmer air and sinking motion of the colder air, that is thermally direct circulation. Acha, this is your zonal kinetic energy to zonal available potential energy to zonal kinetic energy. Then similarly, there is zonal eddy available potential energy to eddy kinetic energy, that is also due by some thermally direct circulation only, but across the eddy. And that is zonal available potential energy, it is generated if there is heating over potentially warmer area, and if there is cooling over the potentially colder area. Similarly for the eddy also. Okay, so these are the different forms of forms are there. And now this is the last one only, that in case of a baroclinically unstable wave, I think this I have already explained in my baroclinical. Thank you very much. So monsoon energetics are there, I am not covering. Thank you. I will stop now.
Thank you, sir. We will take a photograph first, as mentioned in the agenda, and then we will move on to the question answer session. Meanwhile, I'll request the participants to post your questions in the Q&A box. I request everyone to switch on their cameras. Mrunal Tyagi, sir. Mrunal, are you there? Can you take a picture?
Yes, ma'am.
Okay. Now I request Dr. Divya to please moderate the question answer session.
Thank you, ma'am, for giving me this opportunity. As sir, I am very thankful for your lecture. Your lecture is very insightful, and as I can see, there is no questions till now. So I request all attendees, please share. If you have any question, then please write your question in question QA box so that we can take your question.
Excuse me, sir. There are couple of questions in the Q&A box.
Where it is?
In the Q&A box. Okay, I will take those questions. Sir,
Okay.
the first question is by Josen. He is asking, can we extend energetic studies to all the components of monsoon?
Yes, of course. Actually, he is no more, unfortunately. Professor T.N. Krishnamurti, he used to say, energetics is nothing but bookkeeping of all atmospheric motions. Suppose if I get my daughter's marriage, now in the daughter's marriage, which part I have given more stress, more attention, that is reflected by the amount I have spent. So energetics is this only. Any motion you can study using energetics. Any motion, monsoon top, and as such for monsoon there are a lot of energetic studies. The lot means lots. In IITM itself, Rajamani studies are there. Rajamani, using your diagnostic omega equation, he only first explained why southwest sector of the monsoon depression should have maximum rainfall. He only first explained analytically. He has computed each and every term of the diagnostic omega equation, and he has shown that over the southwest sector of the monsoon depression, no terms are contributing negatively. All terms are contributing positively only. The IITMs are also there, Rajamani, then Baiskar. Lot of studies are there in kinetic energy, this thing. A lot of study. We could also try to do a few study along with Sikka sir and other thing. Small studies we have also done. So of course it can be done. Even for cyclone also energetic studies can be done. And of course for western disturbance also energetic study. As such, for any types of atmospheric motion, energetic study can be done. It is very simple thing. Suppose if you consider some atmospheric motion, that means that atmospheric motion must have occurred some places over some period. You just take the data, gridded data for those area for that period and compute all the term and analyze what has happened and find out it's your what is called time series analysis. If we can get it at different stage, which forms of the energy, that means which process. As such, energetic is process. So for example, I have shown C AJ2K. It is a process only. Divergent circulation. It's a process. Suppose if AJ C AJ to KZ is less, what does it mean? Our monsoon circulation is weaker. That's all. Through that value, yes. So of course, it can be done. I hope I could answer your question.
Thank you, sir. So there is another question
Yes.
from Priya Kumari. First, she has acknowledged your lecture. There is one question I want to ask, that how internal energy and potential energy are same?
Same
Because
no, they are not same. They are proportional, not same. That means they are different with a factor, constant factor. It is they are not same. Let me clarify. It is not same. They are proportional. They are proportional. That means their ratio bears a constant ratio.
yeah. So yeah. So you have given the answer. Yeah. Thank you.
It is not same. As such, I understand that I should use minimum mathematics. Otherwise, had I been derived, this question would not have arisen at all. Minimum mathematics. That's why I tried to explain intuitively. Otherwise,
Yes.
it's very simple. 2-3 minutes only. Just step by step derivation, it will come.
So I think there is no other question.
As such, I will be very happy if I can get some feedback, some corrective feedback from my professors, Professor Das, Professor Tagi sir, Mohanty sir, if they are available, because this will be very much useful for me. I can correct myself actually.
Feedback, in fact, every lecture we get the feedback from all the participants, and most of your lectures are rated excellent. So that is the feedback from the participants. Regarding your lecture, of course, it has been extremely interesting. And you are the first speaker who has used the whiteboard to derive all the equations and made the complicated things so simple. Even atmospheric energetics is a very, very important topics, as you have already explained to the participants how many different kinds of energies are hidden inside the atmosphere and how they are so important for the development of the weather system, conversion of one kind of energy to another kind of energy, and so on. And the participants know that really what is the force inside a cyclone, or what is the force inside a thunderstorm. So you can just imagine how much energy is hidden in the atmosphere already and how those energies are generated. If you can really think about, all the youngsters keep on thinking about the innovative things. If you can think of how to harness all those energies which are hidden inside the atmosphere, that will be a great source of non-conventional energy. People are thinking about solar energy. and wind energy and so many things. So you have got so much of energy hidden inside the atmosphere, and the youngsters now, if you can think about how to harness those hidden energy of the atmosphere, then that will be a great thing. So
Yes, sir.
probably it will be a great discovery also. So anyway, thank you so much, Dr. Datta, for your very, very interesting lectures and the nice examples you have given, the live examples that you have given during your lectures of the very, very complex topics.
No, actually, sir, it is Professor T.N. Krishnamurthy say. I went to Delhi. That time he was Somnath Datta Babu. This is nothing but bookkeeping only. When you get your daughter marriage, then every hisab will tell you where you have put more stress. Gahana or sari or pandal or khana.
Right, right. So, in fact, this was the sixth lecture by Dr. Somenath Datta. We wish we could have given him more lectures, probably, or the whole of the atmospheric dynamics series he could have taught in a similar interesting manner, with a very exciting, examples and live examples. But, as you know, we have to also
Yes, sir.
give chances to other speakers.
Yes,
So,
yes, sir. It is
yeah,
always
so
better.
therefore,
always
today will be his concluding lecture. And if possible in future, suddenly we will also once again request him to deliver more lectures if possible. So thank you so much, Dr.
you, sir.
Datta, for very, very interesting lectures.
Thank you, sir.
My request to Dr. Datta is that if he could write a popular book on the atmospheric dynamics.
Correct. Name of the book, sir. Name of the book, to sir. Name atmospheric dynamic. That is very nice book. Is there? That is our
No. Holton is fine. I would like you to, based on your understanding lectures and practical applications,
Okay, sir.
can you write a popular application-oriented atmospheric dynamics?
I will definitely try, sir, with your blessings. Definitely, it is a yes. After my retirement, sometime it will be a great engagement for me.
Exactly.
Great engagement. I am having a PC at my house. I can type also.
No, not. I know you will not sit idle, so that you should
I
not.
will do, sir.
Okay. All the best, and thank you so much.
Thank you, sir.
So, thank you, sir. But before going to the Thanksgiving session, I would like to give statistics for today. 90 participants have registered their attendance, out of which 78 participants have rated it as excellent or very good. So, thank you very much, sir, for this wonderful lecture series which you have given in the last 6 lectures. I request now Ms. Mrunal Naik from IITM and SPPU to please give vote of thanks.
Thank you, ma'am. I will just share my screen. On behalf of the organizing committee, I would like to express our heartful gratitude to each of you for your contribution to this 20th lecture of weekly online series on atmospheric dynamics and its application to climate science. First and foremost, I extend my sincere thanks to Professor Ajit Tyagi sir for his warm welcome address and for sharing his brief overview of this lecture series. My deepest appreciation goes to Speaker of our day, Dr. Somenath Datta sir, for delivering a very informative lecture on atmospheric energetics and for giving his sixth consecutive lecture using a digital whiteboard, creating an interactive classroom-like experience for all attendees. I would also like to thank Dr. Rohini Bahar for moderating today's session and Dr. Divya Prakash for managing the Q&A session. Special thanks goes to all panelists and EC members for their guidance and constant support for attending to every minute details. I also extend my thanks to all participants and attendees who joined us across the globe. Last but not the least, heartfelt thanks goes to team member of Savitribai Phule Pune University for their dedication and behind the scenes efforts in successfully organizing this session. Thank you so much, sir, for the lecture, and thank you for giving me this opportunity.
Thank you very much. I will send the notes.
Yes, sir. Thank you, Mrunal. Sir, we would like to have notes as well as MCQs from you on each of the lecture to conduct the exam.
Okay, okay. I will send.
So thank you all the participants from
Thank you.
joining up across. And the next lecture will be on 21st June, 3 p.m. Indian Standard Time. That will be by Dr. Abdul Madan from Bangladesh.
Okay, so, sir, leaving.
Yes.
Thank you, sir. Thank you. Thank you.
Dr. Divya, can you stop the live streaming?